Hi guys, in this video we will be talking about enthalpies of reaction. Now while we are tackling numericals of this sort, there are two parameters which we have got to keep in mind: standard bond enthalpy of formation and standard bond enthalpy. Alright, now what's the difference between the two? Obviously name suggests standard bond enthalpy of formation. When we talk in terms of standard bond enthalpy of formation, this is how it is represented, and this talks about energy required to form bond. Now suppose we are talking about CH4. Now energy required for formation of one CH bond is say 414 kilojoule per mole. So CH4, it has got 4 CH bonds. So 4 into 414 would be the energy of formation of CH4 molecule. Alright, those many kilojoules per mole. So that would be standard enthalpy of formation. Alright, now coming to bond enthalpy. In case of bond enthalpy, this would be the energy required to break CH bonds. So there are 4 CH bonds, so energy required to break these bonds is bond enthalpy. So in a numerical, you are provided with bond formation enthalpy, standard bond formation. I won't be using the word standard all the time because it's understood, right? So bond enthalpy of formation is provided. Then the formula that you have got to use is this. That is, as I told, enthalpy of reaction would be summation of enthalpy of formation of product minus summation of enthalpy of reactant. Alright, if bond enthalpy is provided, then enthalpy of reaction would be summation of enthalpy of reactant minus summation of enthalpy of product. Please be very sure about which formula you are using when, because normally it is observed that this error is done by many of the kids. So please see to it that you are very sure about which formula to use when. But just to sort it out further, let's get into some MCQs where we would try and understand a bit more in detail. Alright, so let's get into it. Let's try and sort out this sum. The enthalpy of formation for C2H4 gas, carbon dioxide gas and H2O liquid at 25 degrees Celsius and 1 atmosphere pressure are 52 minus 394 and minus 286 kilojoule per mole respectively. Enthalpy of combustion of C2H4 gas will be, these are the options. First thing that we observe is its enthalpy of formation. Alright, so what has been provided is, del FH0. This is what is provided, enthalpy of formation. And then again 25 degrees Celsius and 1 atmosphere, that itself is the standard condition. 25 degrees Celsius means it is 298. You add 273 to that, so it forms 298.15 Kelvin and 1 atmosphere pressure. That's what is standard condition, and that's the reason why this is there. Alright, so these are the values which are given. Now obviously, if now we intend to find enthalpy of combustion, as I mentioned earlier, it would be del H would be equal to summation of H of product minus summation of H of reactant. Alright, so this is sure. Now what do? We just substitute there the reaction. Alright, now we also need to write a reaction. So let's jot it down. C2H4 ethane plus obviously it's a gas plus oxygen O2 gas gives you carbon dioxide plus H2O liquid, carbon dioxide gas. We got to balance the equation. Carbon there is 2 here, so let's put in 2 here. Carbon got balanced. Now let's check out for oxygen. Hydrogen, is it balanced? Hydrogen, no. Oxygen, is it balanced? Oxygen, okay. Let's balance hydrogen. Balanced. So 4 hydrogen done. 2 carbon done. Now we can finally balance oxygen. So oxygen is 2 to the 4 plus 2 6. So we just write over here 3. So this reaction now is balanced. So now what do? We just do summation of enthalpy of product minus summation of enthalpy of reactant. So this would be equal to, in product we have 2 of carbon dioxide, and for carbon dioxide it is provided that it is minus 394 kilojoule per mole. So there are 2 moles of carbon dioxide, so we would multiply this with 2 into minus 394, right? Then we have got for water, that for water it is given as minus 286, so water would be plus 2 into minus 286. So this would be summation of enthalpy of product minus summation of enthalpy of reactant. Now one thing you should be aware of, standard condition, whenever any element is in standard state, we take it as 0. Alright, so we are just to take enthalpy for ethane gas. Alright, so let's jot it down. It has been mentioned over here, it is 52. So it would be minus 52. Alright, whether it comes to minus 788, 2 4 2 9 2 3 7, okay, and then minus 2 6 12, 2 8 16, 7 2 2 4, 572, and minus 52. This all comes to minus 1412 kilojoules. Alright, so the option is B. Okay guys, let's check out this sum. Heat evolved in reaction H2 plus Cl2 giving you 2HCl is 182 kilojoule. The bond energies of HH is 430 kilojoule per mole. ClCl is equal to 242 kilojoule per mole. CH bond energy is, these are the options. How do we do? Now first of all that we have got to understand is heat evolved in reaction is 182 kilojoule. To understand this, let's set up the graph, exotherm endotherm graph. Now in this case, this is HP and this is HR, enthalpy of reactant and enthalpy of product. Now HP minus HR over here would be, now we know HP would be coming here and HR would be coming here. So HP would be much lower than HR. As a result of this, del H would be negative. And this would be exothermic. And this would be evolving heat. So here in this case, we have got heat evolved is 182 kilojoules. So this would be minus 182 kilojoules. Alright. Okay. Now another thing is that they have provided us with bond energies. Alright. So what? So the reaction would be enthalpy of reactant minus enthalpy of product. So this is what we would have. Enthalpy of reaction would be summation of bond energy of reactant minus bond energy of product. Whereas in the earlier numerical that we saw, it was reverse. It was bond energy of product minus bond energy of reactant. Why? Because there it was not bond energies which were provided. It was bond energy for formation was provided. Alright, so okay. So now what do we do? Now it's just a mere substitution. Now here I have already explained. Now since it is heat evolved in reaction, that is, it means that the reaction is exothermic. Thus this value would be minus 182, and summation of bond energy of reactants would be 430 for HH. For HH, this is HH bond, so it would be 430 for HH bond, and then ClCl bond would be plus 242. Alright, so this would be the total bond energy of reactant minus bond energy of product. Now in product, what we have is, we have 2 moles of HCl, so I write here 2 into HCl. That is what we intend to find, bond, right? So now since we intend to find this, so what do we do next? We take it that side and take this side. Alright, so it would be 2HCl would be equal to 430 plus 242 plus 182. Alright, that would be equal to 854. So HCl is equal to 854 divided by 2, that is 427 kilojoules. So the answer would be B again. So guys, what I intend to bring to your notice is, whenever it is bond energy is provided, the equation for enthalpy for reaction that we use is summation of bond energy of reactant minus summation of bond energy of product. Whereas whenever enthalpy of formation is provided, the equation that we use for del RH is enthalpy summation of enthalpy of product minus summation of enthalpy of reactant. Please keep this in mind, because if we commit the blunder of using this equation here and this equation here, this would be the silliest mistake and would never forgive yourself. Okay, so please be careful about these type of numericals. I would be bringing in more such confusing numericals together. Okay, I hope this was quite informative for you all, and all the best.